we can say that when an electron beam is passing and we bring a magnet close to it, basically deflection of electron beam takes place. It can deflect at wrong point and it will hit the wrong point on the screen. As a result, you will see a distorted image. Okay. Now, what is the physics of color TV over here? You know, as I have told you earlier, that in color TV there are 3 electron guns used with 3 basic colors: red, green, and blue. Okay. For example, this is red, this is green, this is blue. Okay. For example, it is hitting this point. Green is hitting, for example, this point, and blue is hitting, for example, this point. Now, if you bring a magnet close to it, for example, I am bringing a magnet close to it. For example, this is north and this is south. So, wrong hitting of points happen. Like how? For example, if you bring a magnet, so this red will hit over here. For example, I say at this point. This blue will hit this point. Green will hit this point. Blue, green, red, blue, green, red, green, blue, red, green, blue, red, blue, red, green. Like over here, if you see, all the points are distorted. They are not regularly hitting a specific point. Just they are hitting the screen at different points. Now, over here, due to wrong hitting, on the screen, you are not seeing a clear image. Over here, you will see a distorted image. Over here, you will see what? You will see a distorted image. Now, let me summarize it once again. What does it say over here? It says when an image is why an image is distorted when a magnet is brought close to an old television or monitor with CRT or cathode ray tube inside. So we can say that when we bring a magnet close to CRT, in which basically electrons are moving, so deflection of electron takes place. Electron deflect either up, either down, and it does not hit the specific point, and we see a distorted image. But what happens in color TV? In color TV, I have told you that 3 electron guns are used with 3 basic colors like green, blue, and red. Okay. Now, when we bring a magnet close to it, so these red, green, and blue hit at wrong points. They hit the screen at different points, and they just hit the screen at different points, not their own specific points. That is why the screen looks you distorted, or you may say that image is distorted. Okay, this was all about question number 4. Coming towards question number 5. Okay, question says that assuming that cathode rays are negatively charged particles, how could you demonstrate that these particles are negatively charged particles? It's quite easier, as we know that electrons are negatively charged particles. Just pass the electrons in an electric field, they will bend towards the positive plate. Just pass the electron beam in a magnetic field, they will bend towards the north pole. Definitely you can show that. Like how? This is electron beam, this is an electric field, and it is bending towards what? Positive pole. Now this is electron beam, this is north and south pole. Look, this is bending towards the north pole. Now it doesn't depend that either it must in magnetic field it must move up. No, if you take the north down and south up, definitely they will move towards the north. So there is no restriction they will specifically bend over upward. No. Wherever there is north, they will bend towards north. Okay. This was all about question number 5. Coming towards question number 6. They are saying that if there are 4 inputs in any logic gates, how many combinations are possible? Do remember one thing. Logic gates are basically those circuits which takes 2 or more than 2 inputs and produces a single output. This is logic gate in personal logical operations. Okay, if we have a single input, we will have 2 outputs, like 0 and 1. Before going further, you need to understand what is 2 power n. 2 power n is basically that formula by which we can understand that how many possible states are possible. So we can write number of possible states 2 power n. Over here n shows the number of states. Now let's analyze. Like if you provide 2 input, how much will be output? If you provide 1 input, how much will be output? If you provide 3 input, how much will be output? If you provide 4 inputs, how much will be the output? Let's understand that. First of all, if for a single input there is 2 output, that is 0 and 1. Okay. Now, if there are 2 inputs, there are 4 output. Like how? Look, 0 are 3 inputs, then there will be 8 outputs. Look, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. This is 8 outputs. Now, if there are 4 inputs, there will be 16 outputs. Please understand. Look, 0 0 0 0 first output, 0 0 0 1 second output, 0 0 1 0 third output, 0 0 1 1 fourth output, 0 1 0 0 fifth output, 0 1 0 1 sixth output, 0 1 1 0 seventh output, 0 1 1 1 eighth output, 1 0 0 0 ninth output, 1 0 0 1 tenth output, 1 0 1 0 11th output, 1 0 1 1 12th output, 1 1 0 0 13th output, 1 1 0 1 14th output, 1 1 1 0 15th output, 1 1 1 1 16th output. This is 16th output, right? So we can say that if there are 4 inputs, there will be 16 outputs, as it's very clearly shown over here. Now coming towards question number 7. What does it say? That what conditions produce high OR1 output for an AND gate and a NOR gate? Please understand. The first we understand what is AND gate. Basic function of AND gate is multiplication. Now let's understand. In the question they are saying that in AND gate, in which case you get output as 1. You have to understand that one. Like when we are getting one output. Please look. Now we are having inputs. Standard inputs. 0 0 0 1 1 0 1 1. Since the basic function of AND gate is 0 into 0 will give you 0, 0 into 1 will give you 0, 1 into 0 will give you 0 and 1 into 1 will give you 1. This is multiplication. So we can say that in AND gate, when both the inputs are 1, you are getting 1. In other words, we can say that if both the inputs are high, then output will be high for AND gate. Okay. We can also say that if both the inputs are on, output will be on, but this is for AND gate. Coming towards NOR gate. In the question we are saying that in NOR gate, when we are getting output 1, okay, like in which case we will get output as 1. So please understand, before understanding NOR gate, we have to draw the table for OR also, so that we can understand NOR. Now standard inputs we are having 0 0 0 1 1 0 1 1. Let's understand what is the output for OR gate. As we know that basic function of OR gate is addition. 0 0 will give you 0, 0 1 will give you 1, 1 0 will give you 1, 1 and 1 will give you 1. This is not 2, okay? This is logic gate. There is no 2 concept over here. There is 0 and 1 because this is digital electronics. Over here this 1 1 addition doesn't give you 2, it will give you 1. Basically, what does it mean? It means that when both the inputs are high, output will be also high. This never means 2, okay? So we can say that. Now coming towards the NOR gate. As we know that the basic function of NOR gate is to produce output exactly opposite of the output of OR gate. So in output of OR gate, we understand. Look, output of OR gate is 0. So automatically NOR will give you 1. When the output of OR gate is 1, NOR output will be 0. This one will turn to 0. This one will turn to 0. So according to the question asked, they are saying that in NOR gate, when the output is 1 or high, so you will see that in NOR gate output is 1 or high when both the inputs are 0 or low. We can say that in NOR gate output is high or 1 when both the inputs are 0 or are low. So this was what about question number 7. Coming towards question number 8. It says what is the algebraic Boolean expressions to represent output of AND or NOT, NAND, NOR. We have already discussed in logic gate in the previous lecture in video form also, and in class we have also done that, right? So let's write the Boolean expressions for different logic gates as mentioned. The first is AND gate. We know that the basic function of AND gate is multiplication. So in multiplication, output or Boolean expression for AND gate is x is equal to a multiplied by b. For OR gate, x is equal to a plus b. Basic function of OR gate is addition. Now coming towards NOT gate. NOT gate is also called inverter. Basic function of NOT gate is to produce output exactly opposite of the output given. For example, if you give 0, it will give you output 1. If you give 1, output will be 0. So Boolean expression for NOT gate is x is equal to a dash. Dash means opposite of the given input. Now coming towards NAND. NAND gate Boolean expression is x is equal to a plus b whole dash. Okay, x is equal to a plus b whole dash. Boolean expression for NOR gate is x is equal to a dot b whole dash. So this was all about question number 7, and this was all about today's lecture. And to summarize today's work, in today's work we have discussed all the conceptual questions, chapter number 16, Introductory to Electronics, and there is no numerical in this chapter, right? To understand that. Okay, so we have finished all the conceptual question of chapter 16. So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz.